Welcome to another video. In this video I'll be looking at partial fractions, and partial fractions will help in integration for some problems, so let's get straight into it. So the first type we're going to be looking at is the fractions that have linear factors in their denominator. What I mean by this is, let's say we have a fraction, say x plus b over cx plus d multiplied by ex plus f. Right? Now this fraction, as you can see, the numerator is ax plus b and the denominator is a product of two linear factors. Factors are cx plus d and ex plus f. Right, and as you can see, we aren't able to cancel anything with the numerator and the denominator, so let's try to go ahead and separate this. Now what you need to note first is that for problems like this, the partial fractions are in this form. Good. So as you can see, a here would just be a constant, likewise the b, and then the denominators for each of these fractions are each linear factor. Okay, now let's just dive into our problem. So let's say we have 5x minus 4 over 2x minus 1 times x minus 2. Good. Ah boy. Good. Now, as you can recall from up here, we're going to write this as a partial fraction, so the numerators are going to be constants, a for some reason my pen is lagging. Okay, we're going to put that over 2x minus 1 and plus b over x minus 2. Good. Now what we're going to do first is to add both of these on the right side. Okay, so let's proceed to adding them, and if we're going to add these, of course the numerator would be 2x minus 1 times x minus 2. Great, same as there. Now when we're adding, we're going to divide the denominator of this fraction into the denominator here, and if we divide this product by 2x minus 1, 2x minus 1 is going to cancel out, leaving us with x minus 2. Therefore we're going to have the a times that x minus 2, and same here, write our b, and that is going to be multiplied by. Now when we divide x minus 2 into this product, we're going to get 2x minus 1 So the 2x minus 1 goes here. Now what you need to note is that since these two partial fractions are supposed to be added to give us back this fraction here, that means the numerator of this fraction must be equal to the numerator of the original fraction. So therefore I'm saying that 5x minus 4 must be equal to a times x minus 2 plus b times 2x take 1. Good. Now with this we're going to solve for a and b. Now in order to solve for a and b, we can choose arbitrary numbers for x, but we're going to choose numbers that make the calculation simple. So first let's choose 2 for x, because here if we choose 2 for x, we'll get a 0 here, which would cancel out the a, leaving us with only the b. Okay, so let's use 2 for now. So for x equal 2, we're going to have 5 times 2 minus 4 equal to a times 0 plus b times, and this would be 2 times 2, which is 4, minus 1, that's 3. Okay, great. So therefore we'll have 10 minus 4, which is 6, which is equal to 3b. Therefore, if we have 6 equal to 3b, we divide both sides by 3 and we get b is equal to 2. Sorry, b is equal to 2. Good. Now let's use this value here and just find a, or what we could do is actually use a value for x that would cancel out the b. So let me do that instead. So let me see, if we choose x as being a half, we would get 1 minus 1 here, which would cancel out the b. So perfect, let's use that. So therefore let me erase the top here. Good. Alright, so we're going to use half, so 5 multiplied by a half minus 4, which is equal to a times a half minus 2, that's negative 1.5, or negative 3 over 2. Good, and plus this would just be b times 0 as stated before. So now let's solve for a. 5 times a half, that's just 5 half minus 4 is equal to negative 3a over 2. Good. Can simplify this by multiplying both sides by 2 if we want to, or we can just add that 5 half minus 4, so that's 5 minus 8 over 2 good, so that's negative 3 over 2 equals negative 3 over 2a. Great. So since the coefficient of the a here is the same as negative 3 over 2, they're equal, so Therefore we can divide both sides by -3/2, which would mean that a is equal to 1. -3/2 divided by -3/2, that's 1. And same thing here, -3/2 divided by -3/2 is 1. So we have a equal 1, b equal 2, therefore we would get 1 upon 2x minus 1 plus 2 upon x plus 2. And of course we can double check this to see if we get back our original fraction. However, you can do that on your own. I'm going to proceed to another type. Don't want the video to be too long. Now we can have linear and quadratic factors in our denominator. So let's say we have a fraction looking like this. Good. And we have dx plus e being multiplied by fx squared plus gx plus h. Good. Now with these types of problems, the partial fractions will look like this. So the linear factor just has a constant in its numerator, plus now the quadratic factor will have a bx plus c in the numerator. That just means it will have some linear expression in the numerator. Fx squared plus gx plus h. Good. Now we have that down. Let's just jump into a problem. Now something that you should note is the quadratic factor here should be one that is not able to be factorized. So because if it is able to be factorized, then the quadratic factor would be written as a product of linear factors, and then we wouldn't need to use that method. But let's just jump into a problem. Over x minus 2 times x squared plus 1. No good. We have our quadratic factor here and our linear factor. So let's just write what they should look like here. Over bx plus c, and as stated above, it goes, the bx plus c is the numerator of the quadratic factor. Good. So as we did before, let's add these. Okay, so, and as I stated before, we would have the same product down here, x minus 2 x squared plus 1. Now when we add, we divide the product here by the x minus 2, which would leave us with the x squared plus 1. So it would be a times x squared plus 1 plus the numerator there multiplied by, let's see now, if we divide the product here by x squared plus 1, then we should get x minus 2, because the x squared plus 1 here would cancel out, leaving us with x minus 2. Good. So now we're going to set the numerator equal to the numerator from the original fraction. So just clear there. Okay. So now, since these partial fractions should add to give you the original, then the numerator here has to be equal to 2x squared plus x. Now, similar procedure, we would choose values that are convenient. So if we choose a 2 for x here, as you can see, this bracket would cancel out 0 times that. So let's use the 2. So for x equal 2, we're going to have 2 times 4, because 2 squared is 4, plus 2, and that's equal to a multiplied by 5. This entire part will cancel out, because 2 minus 2, that's 0. That's 0 times everything here is 0. Therefore, we have 5a equal 10. Therefore, a is equal to 2. Good. Now, let's see. Okay, great. So now for the next one that we're going to calculate, we're going to let let's say we let x equal to 0. If we do that, then the b here would cancel out, leaving us with a and c. So let's just do that. So let's say for x equals 0, we have all of this is going to be 0, because that's 2 times 0 plus 0. Okay, so 0 equal to a, because here will be 0, a times 1 is a. Good. And now b times 0, that's 0, so that would leave us with c here in this bracket, and a negative 2 would be left in this bracket out here, so that's just c times negative 2, which is negative 2c. Good. So we have a minus 2c equals 0, and if we recall from here, a is equal to 2, so we can just plug the 2 in this equation. So let's just bring over the 2c. So we have 2c is equal to a, but remember a is 2, therefore c is equal to 1. Good. And now that we have found a and we have found c, it's easy to just find b. So let's just plug in a value for x. Let's just use 1. 1 is simple. So therefore, for x equal 1, we would have 2 times 1 there, plus 1, which is 3. So 3 is equal to, and that's 1 plus 1, so that's 2a, plus b times 1, that's b, plus c multiplied by, remember x is 1, so that's 1 minus 2, so therefore it's a negative 1 there. Great. So let's just simplify this a bit. So that's 2a minus b plus c. But now remember, that a is 2 and c is 1, so we can just plug in those values. Therefore 3 is equal to 2 times 2 minus b minus 1, because c is 1, so negative 1 times b, that's negative b, and negative 1 times 1, that's just negative 1. Good. So let's just transpose and find b. So therefore b is equal to 4. We're bringing the b over here and bringing the 3 over here. That's 4 minus 1 minus 3. Therefore b is equal to 0. So let me just get a different color here. Let's use red. Good. So therefore this fraction here can be rewritten as 2 over x minus 2 plus 1 over x squared plus 1. B is 0, so that's a 0 times x, so this would be our answer when we write this fraction here in partial fractions. Good. So let's just look at the other example where we have repeated okay, good. Yes, another problem where we would have repeated factors in the denominator. So let's say we had something like that. Good. Over cx plus d and ex plus f, and that f is raised to some power, well in this case it's squared. Therefore that would be equal to a over cx plus d plus b over ex plus f plus c over ex plus f all squared. Good. So let me just go grab a question. Right. Okay. So this in this question where we have 3x squared minus x minus 1 all over x minus 2. Hope I'm not moving too slow. I just don't want to miss anything. Good. Why is my pen lagging still? Alright, so based on what we have up there, our answer should look something like this. X minus 2 over not over plus b over x plus 1 plus c over x plus 1 all squared. Good. Now again let's just add this up so that we can equate the numerator. Now I'm not going to go through the whole addition process. Try and do that on your own, but essentially this is what you should have. And then the b would be multiplied by x minus 2 and x plus 1, and the c would be multiplied by the x minus 2. Good. So now we can just proceed, choose our preferred values that work in our favor. So looking at this, it would be nice to choose x equal 2. So let's say for x equal 2, as you can see, choosing x equal 2 would cause the c to cancel and the b to cancel, leaving us with just the a. Right, so on the left side here we would have that's 3 times 4 is 12 minus 2 minus 1, good, equal to a times 3 squared. Good. So therefore what we have there is 9a. 9a is equal to 9, because 12 minus 2 minus 1, that's 9. Therefore a is equal to 1. Good. And let's choose another value that's convenient. Let me just clear the top here. Guess I'll be using it in a bit. Good. Let's use x equal negative 1. So for x equal negative 1, as you can see, the b will cancel, the a will cancel, leaving us with just c. So for x equal negative 1, we have 3 times 1, which is 3, and that's a minus 1 minus 1. Good. And that's equal to, as I said before, the a will cancel, all of this will cancel, here will cancel, which leaves us with c into minus 1 minus 2, that's negative 3. Good. So we have negative 3c equal to 3. Good, because minus 1, that's plus 1, so plus 1 minus 1, that's 0, which leaves just the 3. So negative 3c equals 3, therefore c is equal to negative 1. Good. Now let's just use x equals 0 and find b. So for x equals 0, on the left side we would have negative 1 equal, because these two terms will cancel out, which is equal to a times 1. Let's get it, a times 1 plus b times negative 2 times 1 plus c times negative 2. Good. So now we have negative 1 is equal to a, and that's minus 2b minus 2c. Great. From our previous calculations, we have a equal 1 and c equal negative 1. So therefore negative 1 is equal to 1 minus 2b minus 2 times negative 1, that's just a positive 2. Great. So here, coming here, we have negative 2b equal negative 1 minus 3. We bring the 1 and the 2 over this side, so therefore we are subtracting a 3. So b is equal to, and that's negative 4 divided by negative 2, so that's just 2. So there we have it, b equal 2, a equal 1, c equal negative 1. All we have to do is just plug those values where they're supposed to go. So a here, that's 1, b is 2, and c is negative 1. So 2, negative 1. Also, instead of writing plus negative 1 over x plus 1 all squared, we could just write a minus sign here. Good. So therefore this is how we would write this original fraction here in partial fractions. So this is it for this video. Please like, comment, share, subscribe, hit me up with feedback. Please guys, share in all the groups that you're a part of. Please, I need to hit 200 subscribers. I'm already past 100. Thanks to all those who subscribed already. Thanks to all those who shared my videos, who shared my channel. I want to say thank you again, and see you in the next video. I guess in my next video I will go through more integration, especially problems that would require you to use partial fractions. So that's it for this video. See you in the next one.